Hello, everybody. My name is Josh. I am a solutions architect here at Pulumi. With me is Mikhail. Mikhail is an engineering manager at Pulumi, and also presenting will be Sagar Lankala, who is a product manager at Microsoft. So a little bit about today's agenda. First off, I'm going to do a little bit of content that explains like the basics of using Pulumi. Then Sagar is, there's a typo on this. Sagar is going to explain about Azure Deployment Environments. The name of the product is Azure Deployment Environments, not Development Environments. That's my mistake. Then Mikhail is going to do a demo, and then we're going to do some free-form question and answers, whatever you might have questions on, and then we will wrap up afterwards. Okay, so a little bit about Pulumi. So what is Pulumi? Pulumi is it's an infrastructure as code platform, and there's two essential aspects to it that make it a useful tool and make it unique among the other tools in the ISC space. First is that Pulumi allows you to use general purpose languages, and the next slide I'll show you specifically what those languages are. And then second, that it works within a cloud. And so that includes, of course, Azure and like all the other major hyperscalers. And I'll get into a little bit more about what that means on a following slide. And there are kind of two parts of the Pulumi platform. There is the open source aspect, which includes, for example, the Pulumi CLI, our policy engine, our providers, which are what allow you to control the resources in the various clouds. That's all open source. And then we also have a managed SaaS product called Pulumi Cloud. So why do you want to use general purpose programming languages to define your infrastructure? So first off, you're able to use familiar syntax. So if you want to write an if-else block, you just write a regular old if-else block in the language that you are familiar with. And speaking of languages, the languages that Pulumi supports. So we support Node.js, that includes TypeScript and JavaScript. We support Python. You can write Pulumi programs in .NET as well. That includes C#, F#. You can even write .NET Pulumi programs in VB.NET if you like. We also support Go, and then we also have Java JVM support that's in preview. So those are the languages that we support. So again, why do you want to use general purpose programming languages to define your infrastructure? So you get to use familiar syntax. If you want to write a loop, you want to write a conditional, you're just using the same old syntax that you are familiar with in whatever language you're using. If you want to get an element from an array or do a slice of an array, well, that's, again, you're just able to use whatever that syntax is in the language that you're familiar with. Second, you are able to use the same tooling that you're familiar with. So if you are, let's say, working in TypeScript and you were using Visual Studio Code as your default IDE, well, you're going to be able to just use that to write Pulumi programs without any additional tooling, because Pulumi programs are just regular old Node programs. So again, autocomplete is just going to work exactly as expected. Unit testing is going to work exactly as expected. Linters, they're all just going to work with no additional plugins. And then finally, you're able to leverage ecosystems, both as a consumer and as a producer. So as a consumer, let's say that you're working in Python, you have some infrastructure that maybe you're creating a bunch of networks and the CIDR blocks are managed by your networking team in some centralized spreadsheet. Well, you can use the Google Sheets SDK to read that information in your Pulumi program and use that to drive the creation of the networks that you're working on. So you can consume pretty much any library anywhere that is in the ecosystem of the language that you're using, import that into your Pulumi program, and use that to drive the infrastructure that you create. Now, that's as a consumer. As a producer, you can also share Pulumi code via whatever your language packaging system is. So if you're writing Pulumi code in .NET, you can just share that as a NuGet package. Same thing applies for Python, PyPI package, Node, NPM packages. So you can just share that code using the same package manager that you're used to. So when we say that Pulumi works with any cloud, of course, that includes all the major hyperscalers, Azure, and the other two. And then also we have a Kubernetes provider that's very popular. We have a couple of, we have a Docker provider that people really like. And then we also support a large range of smaller clouds and also SaaS providers. So we also have providers for things like GitHub, GitLab, Datadog, New Relic. All those are providers that I've used personally and find very, very helpful. And so it's like, if you're writing a Pulumi program and you're using multiple providers, let's say you are spinning up an AKS cluster in Azure, and you happen to use Cloudflare as your DNS provider. So if you have and then you also want to deploy a Kubernetes workload onto the AKS cluster, right? So you would be able to use the Azure native provider to manage the Azure resources like the AKS cluster. And you would be able to use the Kubernetes provider to deploy the actual Kubernetes resources onto the cluster. And then you could also use the Cloudflare provider to affect your DNS, or if you have, let's say, you're using Cloudflare for its CDN. You'll be able to manage and orchestrate all of those resources in a single Pulumi program. And Pulumi is the only tool that allows you to do that and still use general purpose programming languages. So, using different Pulumi providers in the same Pulumi program is not only idiomatic, but it's encouraged, and it's how you're going to really start to see the full power of Pulumi. And it's powerful stuff. So, a little bit about Pulumi's program model. First, at the top level, we have a project. A project is just a folder on your file system that contains a Pulumi program. Within your Pulumi program, you're going to have resources. Resources are going to have inputs and they're going to have outputs. Inputs are values that you can provide. Sometimes they often have default values or they're optional, but it is possible to supply a value for those inputs. And then they're also going to have outputs, which are typically things that are only known after the resource has been created by the cloud provider. So an example of that is, let's say you're defining a network and putting some subnets in that. Well, the CIDR block for the network is going to be an input to the network, and then the output is going to be like the ID of that network, and then you're going to use that to create your subnets. And so when it comes to in practice in like a TypeScript program, these are actual types. It'll be like Pulumi.input of string. And the way these work, they're basically they're very, very similar to promises, if you're familiar with those in JavaScript land. And so they basically contain a value that we will eventually know, and also a little bit of tracking information about what depends on what. And so by using inputs and outputs when you define your resources, that's what allows Pulumi to remain a declarative tool. So Pulumi programs are declarative. It's very important to understand that. So you don't have to say, create this resource if it hasn't already been created. Pulumi keeps track of the work that is done behind the scenes, and it will know what needs to be changed in what order. So when you write your Pulumi program, you're just going to declare your resources in their desired state, and then Pulumi will do the work behind the scenes to figure out what needs to be changed in what order to get from whatever you have to what you want. Okay, so that covers Pulumi programs and resources. On the right-hand side of the slide, we see stacks. Stacks are instances of Pulumi programs, essentially. So use stacks typically to define environments like QA, dev, prod, things like that. Each stack has its own configuration file, and when you run your Pulumi program, Pulumi knows what the currently selected stack is, and it will read values from the appropriate configuration file. So what kind of stuff can you put in that configuration file? Well, really anything you want. There's like specific configuration for the different providers. So for example, in Azure, you might want to say like where, what location you are deploying your resources into. You can set that as configuration value, and you could change that even between like dev, QA, and prod. Another example of configuration values you might want to put in there, let's say you're spinning up AKS clusters and you have different needs for your dev environment versus your prod environment. Maybe in dev, you don't want any log retention and you want to use less nodes and you want less powerful nodes. Well, you can set all those things as strongly typed configuration values in your stack configuration file. And you can read those when you run your Pulumi program, and then you can drive the infrastructure you create off of those configuration values. So you might be creating, again, an AKS cluster, excuse me, and you would store the number of desired nodes in your stack configuration. And then you can read that value when you create the cluster. Same thing with like Boolean values that you can store as configuration values or flags, and then read that Boolean value and then say, oh, if create logs, or set the log retention, you can drive the infrastructure you create off of the values in those stack configurations. A little bit about Pulumi's physical architecture. So on the bottom left-hand corner of this slide, we have our Pulumi program. Pulumi programs, again, can be written in Python, Node, Go, .NET, Java support is in preview, and you can also write Pulumi programs in YAML, which is useful for certain edge cases. Your Pulumi program is going to, the Pulumi engine is going to run your Pulumi program. It's going to take a look at what the desired state of your resources are, and it's going to do a diff against its state file, which by default is stored in Pulumi Cloud. And it's going to figure out what needs to be created, updated, or deleted, and in what order. And the way that it does those CRUD operations are via the various Pulumi providers. So in this slide, you can see that we have the Azure provider and the Kubernetes provider. But if you head on over to the Pulumi registry, which is a link that I will add, you can see the full list of providers that we support. And right now, I believe it's over 160. So I will drop that link over in the handouts tab and let folks know in the chat when it's ready. This being 2024, of course, Pulumi has some AI in the product. If you go to pulumi.com/AI in the browser, you can enter a natural language prompt. And then you can select whatever language you want it to be output in, and it will generate a Pulumi program. The same experience is also embedded into the Pulumi CLI now. So if you go Pulumi New, you can select whether you want to start from a static template or an AI prompt response. And if you select AI, again, you can just enter the language that you want the output in, and then ask it a natural language prompt, and it will generate a Pulumi program for you. So that is Pulumi AI. It's also a great way, by the way, to explore what Pulumi programs look like when it comes to very specific scenarios that might not be covered by an example, or if you're trying to combine multiple providers into the same architecture. So Pulumi AI, very, very helpful. So do check it out. So once again, do create a Pulumi account. It is free. There is a link on the handouts tab. You should have received an email that gives you an invite to an organization. If you just click through on that, it'll make onboarding super easy. And also, it's worth noting that so using Pulumi Cloud, it is free for individual use forever. We do not ask you for any credit card information, and and we do it that way because it's the easiest way to get onboarded with Pulumi Cloud. If you have used Pulumi for a little while, you're thinking about potentially adopting it at an organizational level or at a team level, that's a good time to sign up for a free 14-day trial. We do not ask you for any payment information for that as well, and it'll give you access to the full suite of features that we have available. So with that, let me double check on the questions, see if there's anything to answer. Let me answer a few quick questions, and then I'm going to hand off to Sagar. Are there plans to support PowerShell in the future? So no, not right now. There aren't any imminent plans to support any additional Pulumi languages. That is something that we do revisit periodically, but right now there are no plans to support PowerShell. How often do you guys asked why Pulumi is called Pulumi? Fairly often. So Pulumi is actually a word in the Hawaiian language that means broomstick. And there's a story behind that, but it's a little bit long to get into. But it's a Hawaiian language word. Okay, so with that, I am going to hand off to Sagar. Sagar, please take it away and tell us about Azure Deployment Environments.
Thank you so much, Josh. Hi, everyone. I'm Sagar Lankala, and I'm a product manager in Microsoft, and I'm the product manager who owns Azure Deployment Environments. So for the rest of this session, we'll focus on how you can leverage Pulumi in Azure Deployment Environments. First, let's talk about how Azure Deployment Environments delivers a positive developer experience by helping developers to stay in their flow, focus only on the code that you can write, um, easily deploy and test their applications to help ship high quality code and maximize the productivity. So before we even talk about Azure deployment environments, I'm sure as developers or platform teams that are supporting the developers, we all know how important it is to test the applications as early as possible. I guess we all agree that early detection of bugs or issues is very important and helps us save a ton of effort and money. This slide outlines a lot of research and data. In short, it reaffirms that developers spend a lot of their time fixing bugs, and especially with the increasing complexity of the future ready application, it's even more important to identify and fix those bugs earlier in the software development lifecycle. When we spend so much time on a specific activity, it's important to have a great experience while doing so. But the current processes in gaining access to the application infrastructure that is required to deploy and test our applications early are still very manual, entail a lot of steps and slowing us down. We still see that a majority of enterprise developers have to read through some wiki, which easily becomes out of date, create an internal ticket, have a back and forth with the admin teams before they can finally get access to the infrastructure that they need. And we see it's pretty common in many enterprises, sometimes taking days, if not weeks, to get a working environment. This severely constrains developers to ship high quality code, uh, and it's also not a great experience. At its core, developer experience is all about eliminating toil, and we need to get the mundane workflows out of the everyday life, um, to make it more productive and fun at the same time. That's the reason we introduced Azure Deployment Environments. Azure Deployment Environments is focused on enterprise developers, and it will help you make that shift by empowering developers to self-serve its application infrastructure quickly and easily that is required to deploy and test their applications. Platform engineers or dev leads can securely provide a curated set of project-specific templates and source them directly from a source control repository. Platform engineers can also configure all of the enterprise governance and settings so that they are confident that all the resources, all the cloud resources that are getting created are in adherence with the organizational policies, including the Azure policies that are configured as per well-architected framework. Let's look at both the developer experience and platform engineer experience in detail now. As a developer with Azure deployment environments, as a developer, you no longer need to go through the manual redundant processes to gain access to the app infrastructure. You also need not worry about making decisions on the appropriate subscriptions or the resource groups to use, or even worse, get overwhelmed with all the services that are in the Azure portal, not knowing where to go, what to create, and how to access specific resources. As a developer with ADE, you will be able to quickly and easily get the cloud-based infrastructure by using a curated and customized templates made available for your specific team. You can just provide some basic information that you're already familiar with, like what is the project that you're working in, what is the type of environment that you would like to create, and provide any parameters as required by the template, and create environments intuitively, either directly from the developer portal, as you can see in the screenshot here, or directly from where you live, that is your favorite IDEs or the CLI. So with a few simple steps, you have all the numerous and complex cloud resources that are required to deploy and run your applications. As developers, you also need not worry about orphaned resources that might burn your budgets. In Azure deployment environments, you can configure or pre-configure an environment to auto-expire. Let's say if I'm creating a new environment and I need it only for a week, I'll just configure it to auto-expire in a week's time, and the service will automatically take care of cleaning up all the resources on the specific day and time. So that way you need not worry about orphan resources burning the budgets. One of our primary objectives with deployment environments is to provide a great experience for enterprise developers, make it more fun while building the future-ready cloud-based applications and take the drudgery out. As I mentioned, Azure Deployment Environments is focused on enterprise developers. And obviously, none of this would be possible if the service doesn't integrate well with your enterprise governance that the organizations have in place. So let's look at the high-level workflow of deployment environments here. So as a platform engineer, you can configure the service, or you need to configure the service before developers can start creating environments. You can securely provide curated, customized a set of templates sourced directly from your source control repositories and defined in your favorite ISC framework, in this case, Pulumi, leveraging AD's extensibility model. You can configure the various types of environments that the development teams can create based on the stage of development. And for each type of environment, you can pre-configure the subscriptions in which resources get created and other policies or settings that automatically apply based on the type of environment. You can also configure the managed identities that perform the deployment on behalf of the developer and that provides elevated but controlled access privileges for during the time of deployment. Finally, you can also configure the permissions that the developers would get after the resources are created. So that way, you need not worry about a specific developer or a group of developers having elevated access to resources in Azure. Let's let's talk a bit more about that and about the configuration that you can do per environment type. So the platform engineer, again, you no longer need to spend all of your time performing the same repetitive task day in and day out, or have back and forth with the development teams creating the same Azure resources and granting access to developers. With Azure deployment environments, it enables you to pre-configure all of these settings based on the type of environment. As you can see in the screenshot, like a platform engineer can configure, say that, hey, there is a developer can create an environment type of test, and you can pre-configure what is a subscription in which the resources get created, and managed identities that are actually performing the deployment on behalf of the developer. So once the developer is granted access to the specific project, you need not provide them access to the subscription or the resource group. And whenever the developer is selecting to create an environment, we use managed identities behind the scenes to perform the deployment on behalf of the developer. So that way it's more secure and isolated. You can also configure what are the permissions that the developers would get after the environments are created, and you will be able to configure what is the set of permission that specific developer gets, and also what are the additional permissions that probably the rest of the team gets. You can use your AAD groups or the Entra IDs or Entra ID groups or the user IDs to directly grant that access. Once the environments are created, you will have a centralized view to manage all of the environments that are created. Insights into recommendations from Azure Advisor, including security recommendations, which is top of mind for everyone these days, and deeper cost analysis per environment. So these powerful capabilities help complement the well-architected framework, enforce the right set of Azure policies based on the stage of development, and with the confidence that all the resources that are created will adhere to your organizational standards and governance. The ability to attach your own source control repository as a catalog will help you to easily and securely provide the curated project-specific templates for your development teams. It makes it super easy to version, manage, and even encourage inner sourcing of the templates. And we are taking it up a notch. With AD's extensibility model, you can now configure the environment definitions using any of your favorite IAC frameworks and further customize the deployments based on your organizational needs. You can bring in your own container image, custom container image, and leverage it to perform deployments. The extensibility model provides the flexibility for you to customize the deployment workflows based on your unique needs. For example, one of our customer wanted to invoke internal APIs or systems to retrieve information dynamically, such as IP addresses, IPs that would be used during the resource provisioning. Or there was another customer who wanted to create resources or sub-resources such as namespaces in a shared AKS cluster. With the power of extensibility model, you can customize your deployment workflows and invoke your internal APIs or systems to perform these operations during or before, during, or after the deployment processes. And this is a very powerful tool to customize the deployments based on the needs of your organization. Finally, before we dive into the experiences, to enable our joint customers to take advantage of AD's extensibility model, we partnered with our friends at Pulumi to make it incredibly easy for platform engineers and development teams to perform Pulumi deployments by leveraging AD's extensibility model. You can now directly use the container image published by Pulumi, or can even build your own custom Pulumi specific container image by leveraging the scripts and workflows that Pulumi team has published. You can check out the aka.ms link to learn more about leveraging Pulumi in Azure deployment environments. Now, I'll hand it over to Mikhail to dive in and show us the experiences of how it looks like using Pulumi within Azure deployment environments.
Thank you, Sagar. And my name is Mikhail. I'm an engineer at Pulumi, and I had pleasure to work with Sagar and his team at Microsoft, integrating Pulumi into Azure deployment environments as the first-class citizen of that ecosystem. And I hope you can see my screen now. At the poll at the beginning, Josh shared, we saw that there were roughly two personas on this call: a platform engineer and a software engineer, software developer. And you can think of Azure deployment environment as a product bridging those two groups and making them work together very efficiently. So I'll do a very quick tour of the experience that you get from Azure deployment environments, and then I'll switch towards how you can define environments with Pulumi in Azure deployment environments. So the first persona that we are looking at is a software engineer, software developer. They're working on some business applications, maybe web applications, but that databases and whatnot. They do rely on a lot of cloud resources in Azure, but this is not their job definition. This is not their primary concern. They just basically want it to work. They want the resources to exist, and then they care about the application that they are developing. So in this model, all they have to do to provision a new instance of an environment for their development needs is to go to this developer portal where they see the list of existing environments. They see that this is in context of my login, so I only have environments that I have access to explicitly. And I can click a new environment button here to create a new one, or I can give it a name. I'll do it later on, actually, but I can select the type of environment that I want to get for development, testing. In practice, you'll probably have more. And then I pick some sort of environment definition, which defines what kind of resources are going to be deployed to this environment. And then the second persona is the platform engineer that actually defines the experience of software engineers that I showed before. And their home is at Azure portal, where they work with some resource called Dev Center and define environment definitions inside that resource. Like there's a bunch of options there. I don't have time to go through all of them, but I'll show the ones that are critical for the Pulumi integration. So the first one is the catalogs over here. You can define them on the Dev Center level or on the project level. To keep it simple, I chose to define them on the Dev Center level. And catalogs point your instance of IDE to the GitHub repo or Azure DevOps repo, some repository where the environment definitions are stored. And you can see that I have two catalogs wired here. One is a Pulumi catalog that we provide publicly. So if I click on edit here, you will see that it's pointing to our GitHub repository and Azure deployment environment. These are like standard getting started definitions that you can use to try something out. And then the second catalog is actually mine, is the one that I'm going to use for this workshop. It's on my GitHub repo, and I have it wired so that you could see what I'm building on the next step. So now the second theme is the projects. In practice, again, you will have multiple projects, different developers working on different projects, and platform team has to manage all of them. And there is a lot of flexibility per project. I have a project defined for this workshop that importantly has, again, the environment types defined. And every environment type on the project level defines which subscription I'm going to be deploying resources to and with which managed identity, as Sagar described in his section. So in my toy example, that's the same subscription, but you can imagine you have dev subscription and a separate test subscription. And depending on what kind of workflow the developer is following, the resources will get provisioned in different subscriptions. Now, how do I integrate Pulumi into this? I'll switch over to my CLI. Over here, I have I'll create an empty directory, Pulumi AD workshop, something like that. Go there. And then I'll just create a new Pulumi project as the same way as I would usually when I develop a Pulumi applications, regardless of ADE. I'll accept all the defaults of the Pulumi new command. I'm creating it with C#, which is a popular language for Azure developers, of course. I'll pick a region which is closer to me in Europe. And then the project is initialized and it's ready to go. One more thing I need to do is to create a file for Azure environment definition. So I have one built already. I'll just copy it from the other folder, and then I'll switch over to Visual Studio Code to see what's going on inside the project. So this is a simple project. It has a C# project definition. I'll change it to .NET 8 because that's what I have installed locally. And it's pointing to Pulumi and Pulumi Azure Native, which is our provider for all Azure ARM resources. Then it has a Pulumi YAML file. That's a typical file that every Pulumi project has. Just have a description and the runtime.net. And then importantly, the file that I copied defines the environment for ADE. And it has a couple of fields here that I want to talk you through. Well, first it has a name. Let's change it to something unique. ADE workshop. Summary and description are going to be shown in the portal when developers create this workshop so they could orient themselves better. And then the most important option here for us is the runner option, which points to the container image, a public container image that we developed at Pulumi and published for everyone to use, which has the default implementation of integration of ADE and Pulumi inside of it. You can use that image or you can create a custom one, as Sagar explained, but that's a good starting point if you just trying the integration and seeing where you want to go with it. And then I also need to describe the path towards the Pulumi application. In this case, it's a root folder, but in the more sophisticated cases, you can have folders, subfolders, and so on. You have to point to the root of the Pulumi file in this option. Also, my definition has one parameter. A parameter is something that developers will be able to specify at the time of creating a new environment. I only have one. My toy application is going to deploy a container image into Azure Container Apps, sort of a very simple web app that you can immediately see after deployment. And I need a parameter that actually gets the name of the image to deploy. With that, I can switch over to the main file of the project, which is this one. I'm not sure why I'm getting all red dots here. Is it complaining about this one? No, okay. Okay, I'll go ahead. I'm pretty sure it's gonna work. So the new command created a scaffold of a project. I'll just delete all of this here. I don't need any of those resources. And I'll create something new for my demo. I basically need a couple of resources, but first I need to read the config values that Azure Deployment Environment will provide for me. ADE will create a resource group for my resources, so I need to read a resource group name. So Copilot is sometimes helpful, but sometimes not quite. So it will come in this parameter name, resource group name. So I can just read it from the config and use it for all my other resources. And then, as you remember, I defined the parameter for the container image. It's called just image. So I'll read it as well. And then it's time to define my resources in the Azure that I want to create. It's just two of those. One is a managed environment. So a serverless container app requires a managed environment. Managed environment. Yes, thank you. Let's call it ENV for brevity. and then pass parameters to it. The only one I need today is actually the resource group name. So it knows which resource group to put it into, and everything else stays default. By default, it's going to be serverless environment. And then the second one is actually the container app. Container app, new container app. You can see that I get all the help from my ADE and even Copilot. So like I can use all the tools, compiler help, AI, what name you linters, VS Code, and so on, to fill up a bunch of those. Oh, I don't need all of those. So I'll just take resource group name, again, resource group name. Then I need to pass a managed environment ID. So that's an illustration of the concept of inputs and outputs that Josh alluded to. Like ID here is not known at the compile time. It's passed from the managed environment resource to the managed environment ID in the container app, and that's the way Pulumi will link those. It also creates a dependency between the two, so that Pulumi knows the exact order to deploy those resources. So it knows that managed environment has to be created before the container app. I'll just define that this container is going to be public on the internet so that we could test it out when it's updated. I'll open port 80. Port 80. And then I need to define a template for the container. Template works. Containers. Why is it so helpful today? Just one container that's gonna be app, and then pointed to my image name on default port 80. I think that's all I need. Then the final step towards my application is to get the URL of the deploy container app, which I should be able to just get from last published PDM. All right, I think my project is ready. And if I pull it up, I should be able to build it. Okay, I'm missing an import statement apparently, which is add and add inputs. Try again. All right, still an error. This one is poor casing. And then a typo in the class. Okay. Demo effect, I guess. So I'll run the project locally. One more error, bear with me. Almost there. Last revision of PDM. There we go. So I'm running this project locally. I'm not even doing, yes, now it compiles, so I can set the resource group for my sample local deployment. Workshop. And then repeat this with the other parameter. So here, finally, I have my project working. It's going to create container environment in my resource group, but I'm not going to run it here. I'm going to show you how to integrate it with the ADE. So for that, I'm going back to the CLI. So this is the folder that I created. You can see that I'm actually in the Git context. So that's a new folder. I can add it to my Git repo, live workshop, and then I'm going to push it to my GitHub repository. That way, I can go back to the project or dev environment, to my catalogs definition, and then I need to go here and click sync to make sure that it gets the latest version of my environment definitions. I'll give it a sec to finish. Should hopefully be done. Yes, so sync. Going back to the tool, refresh on this page, make sure that I can see all the environment definitions, and it should pop out right there. So now I can create a new environment. I can see that I have a new Pulumi AD workshop environment definition. That's why the one I created. Workshop live. I'll call it my environment. It's going to be a dev environment. When I click next, I'm asked to provide the container image. I'll do it again here. That's like a simple public web application. And then that's all I need to create a new environment. I click create, and then down in the list of environments, you can see that my workshop live environment is now being created. So this means that AD now creates a resource group for my resources. It pulls the image, the Pulumi image that we provide. And then when the image is ready, it sends the command to deploy my resources. That kicks off Pulumi. Pulumi configures the stack, configures configuration parameters, and then runs Pulumi app deployment. After all of that is done, the resources are going to be available. It takes about 5-7 minutes usually, so I'm not going to make you wait. I have an environment which was created in advance with exactly the same project. And you can see the end result is like this. So you have basically the names and so on, but you also have a button to navigate directly to the resource group of that environment and see which resources got provisioned by Azure. And in this sense, you will see that I have two resources, a container app environment and a container app. And if I click the container app, I should be able to see the URL and actually make you see the web app, which is once it starts, nothing fancy, just shows you how many requests you got, and you can see that Azure environments actually work with Kubernetes and like a bunch of integrations there. So that's that. And then basically what you saw is that I created a new Pulumi project with C#. I defined the resources that I want my developers to have after they provision a new environment. I pushed this into my GitHub repo. I synced that GitHub repo to the catalog of my existing Azure deployment environment. And then I navigated to the developer portal. I clicked the new environment, chose that definition, and in a few minutes, it's going to be deployed and ready for my consumption. I could also set like expiration date and use all other great features of IDE. But Pulumi is now running the deployment both for resource provisioning, resource update, and resource destroy once you don't need that environment anymore. One more thing I want to show before I wrap up the demo is that this repo that we have publicly available to everyone. It's Pulumi Azure Deployment Environments. It's going to be in the handouts of the workshop. It has a few things here that we may find useful. The folder environments contains some samples for the languages that we support and that are more popular: C#, Python, TypeScript, and YAML. So each one of those is a simple project that has the environment definition. Maybe I should take a look at the Python one. Like for Python, it's going to be the same story environment definition in a YAML file, but then a Pulumi Python project, a program in Python that defines your resources, and that are going to be deployed when somebody asks for this environment. So you can those as a starting points. Then another thing is the runner image. So actually, the actual definition of our container image that I was using during the demo, and that is available publicly. But you can also create your own container image if you want to customize Pulumi integration. You can host it in your private instance of Azure Container Registry, and then you just change that one line in the YAML file to point it to your container image, and then it will be used instead of the standard default image that we provide. It's a combination of a Docker file and a couple of scripts. Docker file is built on the base image that Microsoft provides, and then it installs Pulumi, a bunch of language SDKs, and then the scripts that are going to be copied to the image. And the scripts are basically two scripts, one to deploy environment and one to delete environments. And you can customize anything there. Like, for example, I saw a question in the chat whether Pulumi ASC, which is our configuration management product, is integrated with ADE. I would say not by default, not in the default image, but it would be fairly simple to integrate it the way you want using a custom image. So you can use our image as a starting point, but then sort of instead of logging into Pulumi in a standard way, you can use ESC to connect to the environment that you manage centrally in Pulumi Cloud, and then proceed with the deployments using that ESC environment with your secure connection, secure parameters, and all of that goodness. So you can see that the script file bottoms out to call to Pulumi app that deploys the environment, and then the destroy script is going to be the same basically, but calling Pulumi destroy. Well, it's called delete, and then Pulumi destroy is at the end. Once you don't need the environment anymore, you click delete, and that's what that gets called. And the final thing I want to show is a couple of Pulumi programs. One actually deploys an ADE environment for you from scratch. So if you don't have one to play with, you can just use this Pulumi program that defines dev center, projects, environment definitions. That's how I prepared mine anyway. And you can just run this program once, and you will get all the resources and Pulumi integrations out of the box. Once you don't need it anymore, you can just throw the stack and go on any other way. You can also change it the way you want, add environment definitions, environment types, I would say, your catalogs, and so on and so forth. And the last thing I want to show is that we have a GitHub workflow, a simple GitHub workflow. So if you happen to need a custom image for your own integration with Pulumi, you can use this GitHub workflow as a simple starting point to push the image, to build the image, and then push it to your custom registry in ACR. And that concludes my demo, and I'm happy to pass it back to Josh for any wrap-up points and Q&A.
Okay. Thank you, Mikhail. All right, so we did demo time. Now it's time to wrap it up. Again, if you have any additional questions on Q&A, actually, here's a great one. Mikhail, I think I'm going to delegate this one to you because you know Azure probably a little better than I do. So it looks like a two-part question. How does Pulumi handle both Azure multi-tenancy and application multi-tenancy? And then second, how does Pulumi manage cross-tenant authentication and authorization?
Yeah, it would be nice to chat about this question because it sounds like there is a context to it. Basically, like tenants are transparent. Like every by default, you would authenticate with into your subscription, to your tenant and your subscription when you log into Pulumi and you configure a stack. So you'll either use Azure CLI, and then all the authentication methods available there are going to be available for you or with like something like MSI, what AD uses internally. Or alternatively, you can Pulumi has a feature where you can create like your providers inside the program. So if you want to orchestrate resource deployment over multiple tenants, multiple subscriptions inside the same program, then you can create a provider per subscription and then deploy pass that provider as an option to every resource. And this way, Pulumi will know like the exact authentication that they should use for every resource. I hope I answered this question, but I'm happy to engage later on in the details. Like, I don't know, the best place for this deeper conversations is probably Pulumi Slack. So if you're not there yet, please join and ask your questions there in the Azure channel.
It's a great question, though. Definitely not. Definitely not. What is your favorite color? You know what I mean? Like it's a much more advanced question. So, and by the way, thank you to everybody in the audience. The questions have been outstanding for this workshop. I would also add to that like Pulumi providers will typically use whatever credential keychain the cloud or SaaS provider uses. So, for the Azure provider, it's going to be like, it's going to use like whatever it finds via the same way that AZ login and like the Azure CLI finds credentials. It's going to work the same way. Likewise, with some of the other providers, you might use, for example, you might put like some sort of secret as an environment variable. It is provider specific, but in general, it's going to follow the same credential keychain. Okay, so continue with wrapping up. But by the way, if y'all have any more questions, we will try to grab those before we conclude. So this is what we call in industry a call to action. These are things that we would like you to do if you liked what you saw today. First off, please sign up for a Pulumi account if you have not done so. It's going to be the easiest way to run through the examples that you saw today. Second, check out the Get Started with Azure Deployment Environments documentation. That link is also on the handouts tab, but you can find that at aka.ms/ade-get started. And then finally, please take Pulumi AI for a spin. It's a great way to figure out how to what it looks like to manage different workloads on Azure or any of the other providers that Pulumi supports. And it also works in all the Pulumi supported languages. So for example, if you're like, hey, like, I got a feeling for what Pulumi programs look like in C#, but what does the same thing look like in Golang? You can do exactly that with Pulumi AI. So do give that a try. We would also love it if you would join us for an upcoming workshop. Next week, my colleague Diana is going to be doing a workshop to automate builds using Pulumi and Docker Build Cloud. So if you are interested in deploying containerized workloads, this would be a really good way to find out how Pulumi can help you make that possible. Second, we have one that's hosted by my colleague Aaron Friel. It's going to be about how we build AI-powered applications internally at Pulumi. So do join us to check that out. That will be happening after the July 4th holiday in the US, the week afterwards. So that'll be Wednesday, July 10th. And then finally, in August, we have a workshop that we're running with Cloudflare, GitOps in Action. We'll teach you how to deploy a serverless AI app with Cloudflare. And all of those start times, they are all the same time, which is 12 noon on the East Coast of the US. And I want to say 5 p.m. GMT, I believe, or 17 o'clock if you use the European time. So with that, on behalf of myself and Mikhail and Sagar, I'd like to thank you all for taking the time to spend with us to learn about Azure deployment environments and how you can use that with Pulumi. And we hope that you have a wonderful rest of your day.